Kalispera. Ευχαριστώ to be here. I'm sorry, I just know a few words in Greek. I will start very fast and I apologize for my voice, but I was sick. This is the result. And what's DEMETO? DEMETO is a European project where my company is involved. It's based on my research activity. And what we do is we destroy polyester. It means we do depolymerization of polyester. And I will explain you in detail what we do exactly, but it's the only way, chemical recycling, to become really sustainable. I don't know if you know, but just the 12.5% of polyester is recycled, in a word. And for sure, burning is not circular. As well, we know that we have an issue. This picture is very famous, but we talk about this. But the main point is that, I'm sorry, maybe there are no scientific evidences yet that the chemicals are hurting us. But I'm sorry, I don't want to eat a piece of plastics. It doesn't matter. I don't want to eat a piece of plastics. And they are on the food chain. This is an evidence. What we do is that we apply a chemical process, not a mechanical, chemical process to PET in order to do a depolymerization to produce the building blocks. It means the molecules constituting the polymer. We do in a microwave reactor that I invented. We do in a completely circular plant that what we need is electricity, water, and PET waste. And what we produce? The monomers. This one, sorry, I can't move from here. These are exactly the molecule constituting the polymer. And we produce this in the virgin grade, as they come from oil. The environmental impact of this process we have measured, and what we discovered is that if we produce 1 kilo of PET from oil monomers or from monomers produced from us, what we have is minus 67% electricity consumption and minus 38% of CO2 impact. But if we consider that in every LCA the chemicals, they comprehend the end of life, which is incineration or landfill, and we take off this contribution, we have minus 90%, which is probably wrong again, because these are preliminary data. I assume that the CO2 impact will be minus 70%, because it's in the middle. But this is another scientific fact. LCA. I heard many times this morning LCA, life cycle assessment, is the only way to measure the impact of our actions. The rest is wording, narration. The value chain of PET is huge, and it starts from the PET producer. They produce the resin, the polyester, which is used for food containers and clothes, apparels. But guess what? Just 1/3 is used for bottles. The 2/3 are used for textiles. The consumer, they use us, we use as a consumer, and the municipalities, they collect. And what's going on? Mechanical recycle. They do something with bottles. But bottles are just 1/3 of the original resin, not the 2/3. And what's going on? This mechanical recycling flakes of PET, they go back in a little fraction to produce another bottle. But the major part goes to the apparel industry, to the textiles. But what do we do with textiles? What do we do with my t-shirt? Nothing. Nothing. We throw away. We can just burn or landfill. Then this is not circular. Polyester, despite is the polymer most recycled, mechanically recycled in the world, we do nothing. It's linear. Because at the end, we have some littering from consumers and municipalities. But the point is the linearity. Because when we arrive in textiles, or this carpet we are walking on today, we throw away. But if we do depolymerization, chemical recycling, of course we can't avoid littering, but we can take textiles, these carpets, it's polyester, or mechanical recycling fractions, or colored or whatever, and producing the monomer to go where? Back. Back to the beginning. Back to the cradle. Back to the origin. This is circular. Because we continue the loop infinitely. No small loop, a big loop, a middle loop. No, loop. Of course, we take off the colorants. Yeah, 1.5% are colorants. Sorry. Just some evidences. This is our proof of concept. Now we have an industrial reactor. We worked on opaque and difficult to recycle material, deep blue and white. Look at the result. These are the two monomers, the terephthalic casein, ethylene glycol, perfectly colorless, pure. You want to see? Here's the PTA. On top is the molecule coming from typical oil. This is used from Neo Group to produce PET. The bottom one is our monomer, identical. Identical. Back to the cradle. This is another test from Invista, another producer at the beginning. Look at there. Our molecule is identical to the other one. The only difference is the isophthalic acid, EPA, because they introduce on the polymerization is the cousin of the terephthalic acid. It doesn't matter. This was another shocking result. Then we decided to contaminate it with the textile. I took 20% nylon, 20% lycra, or spandex as you want, 20% rayon viscosa. Look, identical to the standard. These are textiles. Back to the cradle. DEMETO is a European project organized in order to create and validate and expand this technology. But not also, because here are the partners. You see there are partners like H&M, you know, I think, of clothes. Because the goal of this European project is not just to validate the technology, but also insert the valid technology in the value chain. But we were not happy. We are open on collaboration. Then we open to an industrial advisory board, inviting all the brands. You recognize many of these brands because they are directly involved on this problem. Then we ask to them, come on board, work with us. Let's gonna figure out how this technology can fit in the value chain to solve the problem. Thank you.
Thank you very much. This is the breakthrough technology, as we say in Europe, and I hope you will succeed, and I will visit the plant in Italy once you have it. Have a nice flight.
Do you have questions?
Anyway.
Go.
Very quick.
A very quick one. It's very promising what you say. Why doesn't go fast ahead? What are the economics? What is the feasibility, the economical feasibility study?
The economical is that the monomers at the moment are competitive on the term of cost with the monomers from oil. Now we did the typical, then which is rare, but we are on scaling up. We started from the lab, testing tube, 30 grams an hour. Then we move on our proof of concept, 1 kilo an hour. Now we are we have 10 kilograms an hour. The next year we start the direction of 100 kilograms an hour. Then pilot plants.
So actually you are in lab scale, not in industrial pilot.
We are in pilot scaling now. pilot. We are in demo. It's bigger than a pilot and smaller. The next one is bigger than a pilot and smaller than an industrial. It's a development of technology.